Hello, grade 9. Today we are going to study lesson 9.4 about transforming quadratic functions. As you know that quadratic functions, it is a function which we have the degree equal to. Then the quadratic parent function is f of x equal x to the power of 2. Then once we have f of x equal x to the power of 2, so we can call it parent function. The graph of all other quadratic functions, the graph for all other quadratic function, f of x equal x square, f of x equal x square plus 1 minus 2, and so on. We are going to represent it graphically, and then we will start to explain what is the transforming quadratic functions. So once we have f of x equal x squared, so we have to find an x of symmetry. So the x of symmetry for this quadratic function is 0, or the y-axis here it was 0, and the vertex is 0 and 0, and the functions has only one 0, which is 0, which is when the parabola intersect with the x-axis, it's intersect at only one point, then we have the zeros equal only one solution, which is 0. To start to compare between two functions, like this, if we want to compare between the width of the parabola, we will order the functions from narrowest graph to the widest graph. Then once we have two different graphs like f of x equal 3x squared, g of x equal 0.5x squared, we will start to find the absolute value for a in each function. Then for the first one, absolute value of 3 equals 3, the absolute value of 0.05 equal 0.05. When we will order the functions, we will order the functions from narrowest to widest. Narrowest, which means it has greater value. Then we have 3 is more than half. Then if I want to arrange them, so it will be 3 and then 3x squared and then 0.5 squared. This is another example. Order the functions from narrowest graph to the widest graph. As I said, narrowest means it has the greater value of a, widest the least value of a. In this question, we have two quadratic functions. The first one was f of x equal 3x squared, and the second is gx equal 0.5. The x squared. Then we will find the absolute value. Absolute value of 3, it was 3, and the absolute value of 0.5, so it will be 0.5. Then the greatest one, which is narrowest one, it was f of x equal x squared, and the widest one is 0.5. And as you see here in the figure, the widest is 0.5, which is half, and the narrowest one was 3x to the power of 2. This is another example. We want to order the functions from narrowest graph to the widest graph. So as I said, we will find the absolute value for a in each one. So we have 1, absolute value of 1, absolute value of half, absolute value of -2. Then if we want to arrange them from greatest to least, so we have 2 and then 1 and then half. Then which one it will be the narrowest one? H of x equal -2x squared. And then we have f of x equal x squared, and the last one is g of x equal half x squared. Then to compare, we have to find the absolute. If we want to represent them graphically, so we will note that f of x equal x to the power of 2, which is the parent function, g of x equal half x to the power of 2. We will discover that this one is the widest one, and we have h of x equal -2x to the power of 2. It will be the narrowest one, and it's downward because the coefficient of x was negative. If I want to compare another part, the next part, we want to compare, so we have to find the absolute value. Then compare the coefficient in the following functions. Compare the coefficient of the following functions. Then it will be f of x equal x square, g of x equal x square minus 4, h of x equal x square plus 3. So we can note here that the value for a in each one are the same, and the value of b equal 0. So this is the first note which we have to talk about it in this one. Then we have the coefficient before x square, or the value of a, are the same and all of them equal 1. And we have the value of b equal 0, but we have different value of c. Then if I want to compare, here in the left side, we compare already the coefficient in the following function. So we compared already the coefficient. But if we want to compare according to the graph, we will find that all the three functions have the same axis of symmetry, which is x equal 0. So this is the first point. The second point, once we look at the position of the parabola, then you will discover that all of them have a parabola upward. So the widths of the parabola are the same, but the vertex of the parabola are different. We will find the parent function, which it was x to the power of 2. The vertex was 0 and 0. X to the power of 2, negative 4. So the parabola was the vertex was 0 and negative 4. And the last one is h of x equal x to the power of 2 plus 3. So the vertex is 0 and 3. So if we want to compare to the graph, if you want to compare the graph for the same functions, for these bunch of functions, so we would discover that they have the same axis of symmetry, the widths of the parabola are the same, the position, all of them are upward, but they have different vertex of parabola. Then if you want to compare, so we can compare the coefficient and compare the graph. The value of c makes this graph look different. The value of c is in a quadratic function determine not only the value of y-intercept, but also the vertical translation of the graph f of x ax squared. The graph of the function f of x equal x squared plus c it will show us if it's upward or downward of the y-axis. Then, when comparing graph, it's helpful to draw them on the same coordinate plane. Then, if I want to compare this set or this bunch of functions, so the first one is f of x equal x squared. So this is the parent function. G of x equal negative quarter x squared plus 3. Number one, we will compare the graph. If I want to compare the graph, then we will discover that the value of a, the absolute value of a here is 1. The absolute value of negative quarter, it will be equal quarter, which means the graph of g of x is the wider one. The graph of g of x is the wider because it's negative x to the power of 2, absolute value equal quarter. So absolute value negative, so the g of x is wider than the f of x. The graph g of x negative quarter x squared plus 3 open downward, and the graph of f of x squared is opened upward. Then once we want to compare, then we will compare between. So we have to put a specific items we will compare by using them, which is, if you want to compare, then you are going to compare the graph. And if you want to compare the graph, so you have to determine which one is wider and which one is narrower. if we are going to compare between which one represent upward or downward, upward or downward, it will depends on the coefficient of x. If it's positive, so it will be parabola, it will be upward. If it's negative, so the parabola, it will be downward. Then if you want to compare a graph, as I said, then you will compare between which one is wider or narrower. Okay, how you will find which one is narrower, which one is wider? Narrower means it has the greater absolute value of a, wider the least absolute value of a. Then let me say again, if you want to compare, then take care to compare the graph, which one is wider and which one is narrower, the upward and the downward. Then for this question, as I said, we compare the graph and then we compare the graph, which one is upward and which one is downward. The last one, the axis of symmetry. Look at the axis of symmetry for both. Then the axis of symmetry for both are the same because both of them have the same axis of symmetry, x equal 0. What is the last point? We can note that the first one, it was f of x equal x to the power of 2. The second was negative x squared plus 3, which means it's a translated 3 units up. It's a translated 3 units up to 0 and 3. So look at the parabola again. This was the original parabola or the parent function. What happened to the second function? It's translated up 3 units. This is another example. Compare the graph of the function with the graph f of x equal x squared, g of x equal 3x squared. So we can note that g of x equal 3x squared is narrower than the graph of f of x equal x squared. Now we will find the axis of symmetry. So the vertex of this one, the axis of symmetry, it will be equal 0, x equals 0. When we will back and substitute in the x squared, you will discover that both of them have the same vertex, which is 0 and 0. And also we will find a coefficient for the first one, x squared was positive, g of x was positive, then both of them are upward. Then now we will use the graph to verify all the comparison which we use it. We said that both of them have the same axis of symmetry, x equals 0, and both of them have upward, and 3x squared is narrower than x squared. The quadratic function h of x equal h of t equal negative 16t squared plus c can be used to approximately the height h in feet above the ground of the falling falling object t seconds after the drop from a height of c feet. This model is used only to approximate the height of falling objects because it doesn't account for air resistance, wide, and other real world problem factor. So the next, it will be a question. Two identical soft ball are dropped. The first is dropped from the height of 400 feet and the second is dropped from a height of 324 feet. So we have two positions now. Write the two height functions and compare their graphs. We said that we have a specific function to find the height, which it was in the previous slide. This one, negative 16t squared plus c. So negative 16t squared, it's the standard, plus 400 because it dropped from 400 feet. And h2t was negative 16t squared plus 324 because it's dropped from 324 feet. Then we wrote already the two functions, the two height functions. The y-intercept c represent the original height. Then We can use the graph to represent them graphically. Use graphing calculator. We can use graphing calculators if you have it, or you can use just enter the value of x and then substitute, or the value of t and then substitute to graph both of them. We will use the graph to tell when each softball reached the ground. The zero of each functions are when the softball reached the ground. The softball dropped from 400 feet, reached the ground in 5 seconds. The ball dropped from 324 feet, reaches the ground in 4.5 seconds. This answer seems reasonable because the soft ball dropped from a greater height height should take longer to reach the ground. Then remember that the graph show here represented the height of the object over time, not the path of the object. Note wides of the parabola. The parent function is y equal x square. Fractional coefficient make the parabola wider. The coefficient more than 1 or less than -1 make the parabola narrower. And we said we can use an absolute value for each of them. If c more than 0, translate c up. If c is less than 0, translate c units down. So this was our lesson today about transforming functions, transforming quadratic functions. And please, you can answer your homework, watch the video again. Don't hesitate to send me any question. Best of luck to all of you, grade 9. Thank you.